Hello, Calculators. Welcome to Marlo's Period A and G Integration Project. Today we will be teaching how to find the area between two curves and how to perform integration by substitution.
In our first problem, we will be finding the area between two curves using integration. Our first curve is y equals to x squared minus 4x, and our second curve is y equals to 2x. To find the intersecting points of these two curves, we set them equals to each other. So x squared minus 4x is equals to 2x. Make it equals to 0 and you get x squared minus 6x is equal to 0. Bring out the x and you have x times x minus 6 equals to 0. X is equals to 0 and x is equals to 6. Then we find y by plugging in x in the original equations. And we find that y is equal to 0 and equal to 12. Now we will graph these two curves using the points of intersection. We do this to find which curve is on top. The shaded region is the area we're trying to find. From this graph, we can see that 2x is the top curve. Therefore, we subtract 2x minus x squared minus 4x, the bottom curve, in the integration from 0 to 6. First, we'll multiply the negative to get 2x minus x squared plus 4x, which is negative x squared plus 6x. When you integrate, you add 1 to the power and the whole thing over the power plus 1. Therefore, we get negative x to the power of 3 over 3 plus 6x squared over 2. When simplified, this becomes negative x to the power of 3 over 3 plus 3x squared, from 0 to 6, according to the graph. So now you plug in 6 in the x's minus the same equation with 0 plugged in the x. So we have negative 6 over 3 plus 3 times 6 to the power of 2 minus 0 to the power of 3 over 3 plus 3 times 0 to the power of 2. If we simplify this, we get that negative 216 over 3 plus 3 times 36, which then gives us negative 72 plus 108, which gives us 36. The area of the shaded region is 36. Now we'll be doing integration by substitution. Suppose we have 4x plus 3 to the power of 5. The idea is that what is inside of the parentheses is u. Therefore, u is equal to 4x plus 3. N is the power, in this case 5. And du is the derivative of u. Therefore, 4 dx. When inserting into the equation, we do u to the power of n plus 1, 6, over n plus 1, 6, times dy, times what was left over from dy, which is the opposite of 4, 1/4, to cancel them out. Then we find the integration, which gives us 1/4 times 4x plus 3 to the power of 6 over 6 plus c. We now multiply the fractions, which will give us 4x plus 3 to the power of 6 over 24 plus c.